Hello everyone and welcome. In this lecture we'll do some examples to practice how to compute the determinant and also how to compute the inverse matrix if exists. We'll start by two simple matrices, so 2 by 2 matrix here and also 2 by 2 matrix here. So we see that to compute the determinant of 2 by 2 matrix is very easy and very simple, so just determinant of A is equals 2 0 0 1 3, which is equals the product of the main diagonal entries, so 2 times 3 is 6 minus product of the main diagonal is 0 times 1, so it is 0, so that means the determinant is equals 0. And once we get the determinant, we can compute the inverse matrix. So we say that A minus 1 is equals 1 over the determinant is 1 over the determinant of A, 1 over 6 times the matrix here is 2 3. We will change these two entries here, so we'll put 3 here and 2 here, and we will take the negative of these two elements, so it is minus 1, and the negative of 0 is 0 itself. So when we multiply here by this 1 over 6, it will be 3 over 6, which is 1/2, and 1 minus 1 over 6, and 0 is 0, and 2 over 6 is 1/3. So this is the inverse matrix of A when we multiply it by A. So when we take A times A minus 1, it will be equals the identity I2, it is 1 1, so we will get here 2 1 0 3 times this 1/2 minus 1 over 6 and 0 1 over 3 must be equals this row times this column. It will be the first entry here in this matrix is this row times this column, so 2 times 1/2 is 1, 1 times 0 is 1, so this is 1, and this row times this column, so it will be 2 times minus 1 over 6 is minus 1 over 3 plus 1 times 1/3, so it is 1/3, which is equals 0. So this element here, or this entry here, is 0. And when we multiply this row with this column, it will be 0 times 1/2, and 3 times 0, it is 0. And this row times this column, it is 0 times minus 1 over 6 is 0, plus 3 times 1/3 is 1. So this is the identity I2. And for B, when we compute the determinant of B, that of B is equals 6 2 3 1. So when we look to these two rows, so this row here, the first row here 6 2, and the second row 3 1, they are proportional. That means when we multiply this row by 2, we get this row. So this, when we name this one here row 1, and this row 2, we get R1 equals to R2. That means the determinant of B is equals to 0, because when we have two proportional rows or two proportional columns, that means the determinant is always equals 0. And when we have also a row or a column of zeros, also the determinant is always equals 0. And when we compute it here, 6 minus 1 is 6, 3 times 2 is 6 or minus 6, which is equals 0. And that means that B is not invertible. As its determinant is equals 0, it means that B is not invertible. Is not invertible. So that means we can't get B minus 1. The inverse matrix of B we can't get. So we can't get the inverse matrix of B, which is B minus 1. So here is another example. So we have here 3 by 3 matrix. 3 by 3 matrix. When we look to this row here, this first row here, and the third row here, they are proportional also. So R3 here, this is R1, so R3 is equals to R1, because 4 here is equals 2 times 2, and 2 is equals 2 times 1, and 6 is equals 3 times 2. So they are proportional, and that means that determinant of A is equals 0. We can of course compute the minors Mij, and then the cofactors Cij, and compute the determinant as we did before. But I will show you a method for computing the determinant for 3 by 3 matrix. So this method I will show you is just for 3 by 3 matrix, and to compute it you can write the element of the matrix of the entries here to 0, 4, 1, 3, 2, 3, 5, and 6, and then write these two columns, the first two columns here. So just copy them here. So write here 2, 0, 4, 1, 3, 2, and then take this element here, multiply this element, and add to them this the product of this element also, and also take the product of this 3 element here, and then subtract from them this element in this direction, so in the opposite direction. So let's me do it. So 2, this will be equals, so 2 times 3 times 6, which is equals 36, plus the product of this element here, 1 times 5 times 4, which is 20, and the product of this 3 element here, 3 times 0 times 2, which is 0 because you have 0 here, and then take minus the product of the sum of this element here. So this element in this direction, and this element also in this direction, and this entries in this direction. So it will be 3 times 3 times 4, which is 36, and 2 times 5 times 2, which is 20, so plus 20, and this has here 0, so it will be 0, 1 times 0 times 6, which is 0, plus 0 if you want, and this will be 36 here, 36 plus 20, minus 36 minus 20, it will be 0. So as we expect, because we say here that determinant of A is 0, because it is clear, because we have here 2 proportional rows, and that means that we the A is not invertible, not invertible, so we can't get A minus 1. And here we have 4 by 4 matrix. So the examples that we have seen before are just 2 by 2 and 3 by 3 matrix. Now I will show you how to compute it for a bigger matrix. Usually when we have a big matrix like 4 by 4 or 5 by 5 or 6 by 6 matrix, usually we use logiciel like MATLAB, for example, and compute its determinant and then or its inverse matrix if it exists. Also we can use for example a programming language to write a function or to define a function to compute for us the determinant and the inverse matrix. Or you can use also a library like NumPy, for example, to compute it. So usually we use these tools to compute the determinant and the inverse matrix of a big matrix. But I will show you just this one for practice. So the determinant of B, to get it, will need to compute the minors and then the minors ij and the cofactors. So to get the minors of this first element here, the first entry here, it will be m1 1, m1 1, which is the minor of these two here. So we'll read this row with this column. So this array, I'm sorry for my pen. So we'll take the remaining matrix here. It is 3 2 1 and 5 6 7 2 8 0. So this the remaining matrix here. This determinant is equals. So when we use the method that we have seen in the previous lecture, we will write these two columns here. So it will be here 3 2 1, and let me read this, and the second column here is 5 6 7, and then take these entries here and these ones here and these ones. So it will be equals 3 times 6 is 0, 5 times 8 is 40, 40 plus 0, so 0 for these first ones, 0 plus 40 here 2 times, so it is 28 minus the element here 2 times 6 times 1 plus 3 times 8 times 7 plus this 5 times 2 times 0. So 2 times 6 is 12 plus 3 times 8 times 7. So 3 times 8 times 7 is 168, and this 5 times 2 times 0 is 0. So well, this is equals, so this is equals minus 112. And when we take m12 is equals the determinant of, so we will now raise this to, so now we are concerned in this entry here, so we will read this column with this row, and the remaining will be 140 and 5 6 7 and 280, and then we also apply the same method, 140 here and 568, 567, sorry. So multiply this element here and this ones here and this element here, it will be equals here 0, and here also 5 times 8 times 0 is 0, and 2 times 4 times 7 is is equals 56 minus this one's here, so 2 times 6 times 0 is 0, and 1 times 8 times 7, and 5 times 4 times, so this is 0, so it will be also 8 times 7, which is 56, which is equals 0. It is clear here when we look to this row, this column here and this column are proportional, so its determinant will be equals 0. And when we do the same here for m1 3, which is equals, let me write this once here, m1 3 is equals, here it is the minor for this entry here 3, so we will arrange this row with this column, and we'll get this matrix, which is 1 3 4 2 0 1 and 2 8 0, so 1 4 0 3 2 1 and 2 8 0 2 8 0, and write these two columns here, so 1 4 0 and 3 2 1 3 2 1, which is equals, these entries are 0 and this also are 0, and this one is 2 times 4 times 1 is 8, minus these entries here are 0, and this one here are 0 also, and we'll get this 8 here, so it is minus 8, which is equals 0. When we look also to these columns here, are this first column and the third column are proportional, so it is normal to get its determinant equals 0. And to get the determinant of the m1 4 for this entry here 4, so let me write this as, so we'll write this row with this column, and the remaining matrix will be equals, so I will write this to get space here to compute and 4, so it will be equals 1 1 4 0 3 3 2 1 5 6 5 6 7. We'll use the same method here, so 1 4 0 here, 1 4 0 and 3 2 1, it will be equals these elements with these ones here is 0 and this element, so this will be 2 times 7 is 14, 2 times 7 is 14, plus 4 times 5 times 4 is 20, because here is 0, so minus these ones here are, this one here are these elements is 0, and this also, and this one, so it will be minus 6 times this is 1, or 6 is 1, yes, 6 times 1 times 1 is 6, and 3 times 4 times 7 is equals 48, this is plus 48, which is equals, so this is equals minus 56. So to get the determinant or to compute the determinant, I don't need to compute all the determinant, all the minors and cofactors for the other rows. So for us it's the first row is enough, or any row is enough for us, or any column, because we can get the determinant from it. So first we need to compute the cofactors for this row, so C11 will be equals minus 1 power 1 plus 1, which is 2, times m11 m11, which is equals m11, so it is minus 112. So here is m11. This minus 1 here is square, so it will be equals 1, and it will be m11, and this minus here is come from here, from m1, and c12 is equals minus 1 power 1 plus 2 is 3, so it is 3 m12, but m12 is 0, so this is 0 because here will be minus 1 times 0 is 0, and the same here c13 is 0 because m13 is 0, so c13 is equals 0, and c14 here is equals c14 is equals minus 1 power it's minus 1 power 1 plus 4 is 5, so 1 plus 4 is 5 m14 this will be equals minus 1 is power 5 is minus 1, and m14 is minus 56, so it will be minus 1 times 56 will be plus 56. We will get 56. So I will read this space here because I will need it to compute the determinant. So the determinant of b will be equals we'll go with this row, so it will be 2 times c11, which is minus 112, and these two ones are 0, so c12 and c13 are 0, so this will be 1 times 0 plus 3 times 0, so will be 0, and we'll get this 4, so it's minus or plus 4, this 4 here times c14, which is 56, and this is equals 0 as we expect. So as we expect, the determinant is equals 0 because we have here two proportional rows, so this row here, and this row here are proportional, and also these two columns here, the column here and the column here are proportional, so the determinant is normal to be 0.